Okay, let's get started. Hello, everyone. Welcome. It's last day, last session. So very excited. A little bit of logistics in the beginning. So if you want to ask any questions by voice, you can we can do it at the end of the session. Otherwise, I have Slack channel here. So if you have any question, you can just write them on Slack. So that's all about logistics. So let's get started. Welcome, everyone. My name is Evgeny Borzenin. I'm a cloud solution architect and consultant at a company called Enso. And today I'm going to talk about immutable infrastructure on Azure and on VIPs. Just to set some expectations for this talk is mainly an experience report of our journey towards immutable infrastructure in VIPs for the past 2 years. And I actually had the privilege to be part of Team Platform and be part of this journey. So this is my first talk on such a big conference, so I'm both really excited and extremely stressful. So, but first, let's start with VIPs. So for those of you who live in Norway, I don't need to introduce VIPs. You know what VIPs is. For those of you who don't live in Norway, VIPs is a #1 mobile payment solution in Norway. So, and it becomes so popular that VIPs now become a verb. So in Norway, we don't send money, we VIPs money. 70% Norway population use VIPs every day, and that gives us 3.6 million active users and more than 100,000 of companies using VIPs. So VIPs is expanding the business, and now you not only can transfer money to your friends, but also can pay with VIPs for your tickets on the bus or from a web shop. And VIPs operates at a very competitive market, and it's really important that we have a very stable and reliable infrastructure. So VIPs constantly release new features, it improves existing functionality. So basically it's changing and evolving, and so does the infrastructure. So it all starts with on-prem version on DNB, because DNB was the bank that initially started VIPs as a product. So, and on DNB it was a bunch of Java applications running on virtual machines. So, and then it was lift and shift to Azure, and that's when VIPs started the journey towards Azure. So, and lift and shift means that it was same virtual machines and same Java applications, but now they were running on Azure. So then VIPs started to decompose the monolithic application and introduce microservices, and then start to containerize those services. And at that time, AKS was not mature enough product, and therefore VIPs uses DCOS Kubernetes platform. And from infrastructure perspective, this DCOS was a bunch of virtual machines maintained by VIPs, where all containers were running. So, and therefore it was a very logical step to then migrate from DCOS to AKS, because AKS, it's a managed Kubernetes service on Azure. So, and that was next step. And the last thing, and that's where we are now, we call it embrace the cloud. And basically we're trying to adapt our system and restructure, re-implement things. And we try to utilize Azure as effectively as possible. And now if we climb up and look at the VIPs infrastructure from bird's perspective. So what we see is that, first of all, it's 100% on cloud, and it's 100% on Azure. So, and that's infrastructure how it looks now. As I said before, it was a lot of evolutions, but still now it's a good mix of infrastructure as a service. See here, so where we have some support systems or some legacy stuff running. Then it's platform as a service with a variety of the products. We use SQL Server, Cosmos DB storage account for data storage. We use Key Vault for sensitive data. For example, Event Hub Service Bus for messaging and PubSub. and many, many more other products. 90% of workload in VIPS run on AKS, Kubernetes service, and 100% of APIs exposed with API management. And 90% means that some of the workload is not running on AKS, and that's why some of the teams who are autonomous, they decided that the application that they develop, they doesn't fit well in AKS, and they, for example, use Azure Functions or Azure services for their workload. So that's why it's only 90% here. And then for CI/CD pipelines, we use Azure DevOps. But today we're going to talk about this guy in the middle, so something we called VCE, and let's talk about it in more details. So VCE stands for VIPS Core Engine. And VIPS Core Engine is basically a set of infrastructure components treated as a one unit. So it consists of a private virtual network with a predefined set of subnets and a network security group associated to the subnets. Some peerings with another private VNet for integration or for different support systems. It's AKS with, today we have more than 100 deployment units or services. And as I said, it's 90% of workload running on AKS. AKS deployment model is it deployed into private VNet. That means that it's not publicly accessible. And to expose functionality of the applications running on AKS, we use API management. And today we have more than 100 APIs deployed to APIM. Again, APIM deployment model is that it deployed into private VNet, so it's not publicly available. And to securely expose publicly phased APIs, we use application gateway. And as I said, we have much more stuff. We have application insight and log analytics for logs and performance metrics. We use Key Vault for sensitive data and managed identities and a bunch of other stuff. So, and this version that I'm showing now here is very strict view of kind of the real components. But at the same time, it gives us some sense of complexity that we operate with. So now let's see with such a setup, what kind of operational tasks we may expect and what kind of challenges will it give us. So basically, VCE started when we did the migration from DC OS to AKS. So, and that's basically we provisioned a new cluster, we migrated all services from DCOS to AKS, and then, somewhere middle of 2019, this first version of VCE was out. And since this is AKS, one thing you need to know about AKS is that the support model in AKS works the way that every time when AKS product team releases a new version, major version, so they terminate support for previous versions. So for example, this week they releases 1.17, and that means that 1.14 version is out of support soon. So we are not an exception. So when we had this in production, so at some point we needed to upgrade our cluster. So, and we in production, so all traffic is actively going through. So now we need to upgrade. So what do we do? So basically it's very simple. You go to either portal, or you run the script, or you run an ARM template, or you run a Terraform, or whatever. That depends how you maintain your infrastructure. Somehow you trigger the upgrade. And then in our case, 3 hours later, we are running on the next version. So one thing to point here is that we did it with active traffic going through the system. So we did it on the same resource group. We did it on the same VNet. So basically, we just updated existing Kubernetes instance. So, and sometimes it works fine, sometimes we had some issues, but in general, it was okay. So, and then sometimes after we run things in production, we realized that we actually over provision our cluster. So the choice that we made on the size of the VM instance was wrong. So basically we over provision our cluster. And AKS is the product that some of the things you can update, but some of the things you can't. And if you need to, for example, change your VM size, you need to reprovision your cluster. So we needed to do it. And how do we do it? So we need a new subnet. Then we need to deploy a new instance of AKS cluster. So then we need to deploy all our application and services. So then we need to test services. So and actually here, the active traffic is going that way. Now we have another instance of Kubernetes running in isolation, and we have some possibility to test actually. So we not able to do end-to-end testing because otherwise we need 2 more components of things here, but we do possibility to have some testing of how our applications are running on new cluster. So and when we are confident with our services, we do switch. So we're switching from on APIM and pointing all traffic to new backend or a new AKS cluster. So for example, if something goes wrong, we can always switch back. So, but if we are happy with how things work, we can just decommission the old one, and yeah, we are running production. Then shortly after we released VCE 1, application gateway version 2 was released. And version 2 was much better than version 1. So first of all, they improved the operational performance. So things that took 20 minutes on version 1 now takes 6 minutes. Still a lot, but much better. And also the App Gateway team, they introduce a few very practical features like auto-scaling, zone redundancy, and ability to configure your App Gateway that SSL certificate is read from key vault, and then when you need to renew your certificate, you do it on the key vault, and then you don't need to do anything on the application gateway. So basically we decided, yes, we want to upgrade. And how do we do it? So version 1 App Gateway and version 2, they cannot be deployed to the same subnet. Then we need another subnet. Then we deploy application gateway. So traffic still going through the old one. And now actually we have possibility to do some end-to-end testing, because now we can have a mobile application that, for example, calls, and we can test new App Gateway, or we can test how system works with new App Gateway without affecting the existing customers and existing setup. So we do some testing. If we are happy, we switch the traffic to the new instance. We can keep the old one for a while, because if something goes wrong, we can switch back. And then we do cleanup and we remove the old instance. So basically, we were running things in production. We did several retrospectives. And what we identify is that the upgrade operation was a very high risk operation, because you upgrade instance which is running in production with active traffic. And for example, if upgrade fails, then VIPS is down. And that's definitely something we don't want VIPS to be. So, and because of that, because of this active traffic and high risk, the AKS upgrade needs to be coordinated with the command center, and we need to find maintenance window when we are allowed to do it. We need to identify what is the point in time when we have the minimum amount of traffic through the system. And that's normally weekend at night. It's also very high stress operation, because the person who is doing this upgrade, so imagine that you are this person and it's night and you click this upgrade button, and then for the next 3 hours, you have no idea how things will be. So it may be okay, but it might be some issues. So, and that like high stress, high risk operation gives us kind of the feeling of fear to upgrade. So we want to postpone this moment as long as possible. So and also with AKS upgrade, we can do end-to-end testing, and that's about upgrade. And then at the same time, AKS reprovisioning was a completely different story. So even though it sounds like, oh, reprovisioning, so that's a very complicated thing, but in reality, it was a very good thing because it was very low risk operation. Because like we have the current traffic going to the old one, we can provision new AKS in isolation, we can test things before we switch the traffic. And yeah, so you can do it actually on daytime, so you don't need to find this maintenance window. So it was a very good experience. At the same time, so still was not possible to do end-to-end testing because the cluster is sitting in isolation in private VNet. But in general, it was a very positive experience. Same with application gateway version 2. So it was a very low risk operation. You introduce new instance in isolation, you can test it before you open it up for the active users. And in this time, it was even possible to do end-to-end testing. And in neither of those three scenarios, canary testing was not possible. So, and at that time, we start to plan how do we want our VCE vNext version to look like. And that was the time when we started to look into mutable versus immutable. So what is mutable? What is immutable? And just to kind of properly introduce this term, let's look at what is mutable infrastructure. So mutable infrastructure means that infrastructure that liable to change. So it's infrastructure that is capable of being modified and updated in place on a regular basis. So, and if you look back to our VCE1 version 1 version, so that was definitely a mutable infrastructure, because when we upgraded our AKS cluster, that was the same cluster that we upgraded at the same VNet, at the same resource group. And same goes with when we introduce a new cluster or a new application gateway. So when we added subnets, that also was a fact of mutability, because we changed existing VNet configuration. So, and just to repeat the things that are associated with mutable infrastructure, that's high risk operation, because you changing thing that already serving traffic. It's high stress, and if you're to upgrade, you need to find maintenance window, and in our case, we can do end-to-end testing. At the same time, immutable infrastructure is kind of opposite, so it's antonym to mutable. So immutable means that unchanging or unable to change, or this is infrastructure that once being provisioned cannot be modified. So you never change it. So if you need to change, you provision new infrastructure. So and if we look at the VCE1, this is also a little bit of immutable as well, because when we reprovision our cluster, AKS cluster, and when we added new instance of application gateway, that was an act of immutability, because we didn't upgrade the existing instances, we introduced new instances. So, and with those two terms in place, we started to plan our vNext iteration of our infrastructure components. And we said that we want VCE to be immutable. So that means that when it comes to AKS, so either this is upgrade or reprovisioning, for us, we treat it as the same operation. So we also said that we want to be able to very easily introduce or replace components in our infrastructure. So we also want to have possibility to do end-to-end testing before we open a system for the users. And we want to be able to send small percentage of the traffic to the new infrastructure and see how system react and work under the new infrastructure. So then we defined some conventions. So we introduced a concept of slot. So that means that each environment will have two slots, blue and green. And also one resource group, which will be base, where all shared components and resources will be deployed. An example of these shared components will be log analytics, application insight, key vault, and other things. But slots, that's basically it contains same amount of infrastructure components, and at some time they can be actually running in parallel when we do a switch. And now with this convention and definition and requirements, let's see how upgrade lifecycle will look like in this new infrastructure. So let's say we are running Blue as an active production environment now, and we are running on version, for example, 1.15.10 AKS, and we want to upgrade. So what we do, we actually provision completely isolated set of infrastructure components, exactly the same resource group, but of course with different name, same set of VNet with subnets, application gateway, APIM, AKS. So then we deploy services. So in our case, we export from AKS and import to a new one. With APIM, what we did, we backup and restore. So then you do end-to-end testing. So we can test it from here, and the active traffic still going that direction. And then we can actually do a canary testing. So we can say, okay, I want 10% of the traffic go to green, and 90% of the traffic still go to blue. So and then, for example, we run it for a while. If we see that things works great, we can send 100% traffic to the green. We can still keep blue for a while, because if you see that green doesn't work, we can always get back to the blue, and eventually we can decommission the blue infrastructure. So and now the green one is the active environment. So now let's say we want to introduce new component. We want to have another instance of an application gateway that will communicate with AKS directly by passing the APIM. So how do we do it? We provision new infrastructure. So now we see we have two instances, and this one talks directly to AKS. We deploy our services. Now we export from green, import to blue, backup from green, restore to blue. We do end-to-end testing. We do canary testing. And if things goes as we plan, 100% switch and decommission the old environment. So now we are on blue, and then next infrastructure change we do on green, and then blue, green, blue, green, and then it's basically never endless loop. And it was very positive experience. So basically now all our operations are low risk operation. We can do things anytime we want. So we can plan it, and we can apply it at daytime. So it's like zero stress operations. We can test things both without affecting the existing users and actually sending the users to the new infrastructure, like small percentage of traffic. It gives us flexibility, because now we can do things when we want, how we want. And for the system as a whole, it gives us a stability, because system is much more stable. So we can upgrade things without almost close to zero downtime. And for us as a team platform, it gives us a confidence that yes, we can do these things. Yes, we can upgrade our infrastructure. Yes, we can replace component without being afraid that we can affecting our customers. And of course, nothing comes for free. And the cost here is complexity. Complexity means that we have multiple environments. So we have, for example, test, then Q&A, stage, production. And for each environment, now we may have two set of infrastructure components running simultaneously when we do the switch, or if we enable canary traffic. So it also requires really, really heavy investment into automation, including provisioning, post-provisioning configuration, and deployment. It also requires quite good coverage of end-to-end automation testing. Because if you don't have end-to-end testing, then you need to coordinate with product teams And then you need to have a representative from each product team during the switch. Because when we switch our infrastructure, we need to be able to test our functionality. And we as a team platform, we have no idea how things work. That's the responsibility of product teams. So if we can avoid this, that's better, because if you have dependency to other teams, then coordinating between teams, that's always a hassle. And of course, your application should be immutable ready. So but normally, if you are in AKS, then most likely your application's already ready for being immutable, because they will be running on not now in multiple pods, but can be multiple pods on multiple clusters. But still, we actually hit some cases when it was some batches that were running very frequently, very rarely. So for example, every night, and then suddenly when we had the two clusters, like the same batch run on both clusters, and then a batch itself was not ready to be run on multiple places, and then it was some issues. So just be aware of this. And of course, state. So stateless components make your life much more easy, because yeah, you should try to avoid any sort of state in your infrastructure. And in our case, we were very lucky because all services that we run on AKS, they're stateless. So that means that we can just move them to a new cluster without any issues. Right, and in fact, the production environment, we did this switch on Monday this week. Basically, all other environments we did several iterations, because we deployed to blue, then we switched to green. So basically, we did 2 switches per environment, and production we introduced it Monday this week, which was very successful switch. And now we currently start planning the next iteration for these VCE components. And one of the things that we don't like in current setup is that this guy in the middle, APIM, actually has a state. So APIM has a database where subscriptions and user data is stored. And during the switch, that may, especially if you have a canary traffic, that may cause us a problem, because if we are testing some processes that involve creation of the resources on the APIM, then we may have a kind of out of sync instances on blue and green. So today we handle it by announcing on organization that we do a switch, and please don't run those processes. But in future, we want it to be automatically solved by itself. And therefore, we are planning to actually move APIM from this blue-green into this base resource group. But that of course, gives us some complexity, because now traffic will travel like from traffic manager to blue, then out from blue back to base, and then back to blue. And when we are in canary mode, so then we actually need to implement a policy on APIM that will orchestrate the traffic between 2 clusters. So that means that we need to be able to specify the percentage of the traffic that we want on both places now, on front door or traffic manager, and on APIM. And another thing we want to replace is we want to try front door instead of traffic manager. But other than that, so we're really happy with our setup. It gives us what we plan to implement, and it works really, really great. Now let's switch our gear towards infrastructure.AsCode. Because as I mentioned before, automation is really, really important. And it doesn't really matter whether you have mutable or immutable infrastructure, you should automate your infrastructure. And that's like infrastructure.AsCode, very popular term now. And what it means is basically you treat your infrastructure as code. It should be stored in source control, and changes that you do on your infrastructure should be done through pull request. And then some of your team members can do a review. And yes, and when the merge is done, then your infrastructure should be deployed with automated scripts or deployment pipelines. And there are a bunch of products in the market. So ARM templates, Terraform, AZCLI, different SDK for different languages, PowerShell, Pulumi. And in fact, in VIPs, I think we use most of them because different teams provision, some of the teams, they provision infrastructure themselves, and then they use Terraform, or they use, for example, Python script that generates ARM template based on different logic. So, but for VCE, we decided that we're going to use ARM templates as a deployment unit. But since nobody likes to work with ARM templates, we decided that we will implement a tool that will generate ARM templates for us based on configuration that we define. And for this tool, we call it deployer. And that's basically infrastructure.AsCode for our VCE components. And here is some requirements that we gathered for our deployer. So first, convention over configuration. So the only parameters that you need to provide to deployer is environment and slot. And then, and also you can specify what kind of resource you want to regenerate or redeploy. So, and the rest of the things deployer can do based on the conventions. And conventions can be something like, we can say that in our VNet, we have 5 subnets, one for AKS, one for APIM, one for app gateway, one for Bastion, and one for gateway integration. So 5. And then for each subnet, we have a convention, what is the size of this subnet. And then the only thing that we have in configuration is the base IP address for the VNet. And the rest of the things, deployer will automatically calculate what will be the IP range for each subnet, and it will generate the ARM template, and you don't need to actually work with ARM templates. Implementation-wise, deployer is a CLI tool. So that means that I can run it from my computer, or I can run it on a Azure DevOps pipeline. And if Azure DevOps for some reason down, so it's fine. I can run it from my computer. So basically, we use the same script to deploy from computer or from the pipelines. Deployer is a self-contained tool. That means that if I have deployer on my computer, I can generate templates, artifacts. I can upload them to storage account. I can download them from storage account. I can validate ARM templates, and I can deploy ARM templates with deployer. So deployer does everything for us. Yes, and traceability, of course, it's very important. Therefore, we spend quite a lot of time implementing this tagging strategy. How do we tag our resources? Because it's really important to be able to identify where did I deploy this infrastructure, who deployed it, like where is this version of Git hash tag that indicating the changes that I deployed. So, and that's all implemented with a deployer. And like structurally, deployer has the concept of configuration, where we specify our environments. Then it has a folder with predefined ARM templates, and that's actually the only place where you need to work with ARM templates. But the way how we do it normally is that you can manually create what you need in Portal or with AZCLI, and then you just export the ARM template, put it to the templates, and teach deployer how to replace some stuff in the ARM template. But some of the templates we generate from scratch. For example, application gateway ARM template, it's totally automated because we have in some of the environments, we have some differences between how we configure app gateway, and then it's totally not possible to do just with ARM templates, but it's very easy to implement with C# that generates ARM template for us. So, and then when you have configuration and template in place, you run deployer with like deployer generate -r, and then you can specify what type of resource you want to generate. If you say all, it will generate everything. You can say up gateway, it will only generate up gateways, or VNet, and so on and so forth. And then you specify what environment you want to generate things for, and what is the slot that we're going to deploy things to. And then what deployer does, it gets a configuration, templates, and yeah, transform things and generate a set of artifacts. And artifacts contains of ARM templates, then a set of Bash and PowerShell scripts, and Kubernetes manifests, and metadata. And metadata contains information about a subscription, resource group that we're going to deploy things to. So, and then artifacts deployed to, uploaded to storage account, and then deployer can download from storage account and can validate and deploy things. So, and when deployment is done, so then we run post-deployment configuration. And that means that, for example, we need to configure our cluster with namespaces and some, yeah, so basically a lot of post-provisioning configuration steps. And normally we have a master script that we just run like deploy dev blue, and then it does the rest of the job. And just to give you some sense of how the configuration files look like. So again, convention over configuration. A lot of things we specify in base folder. So, and if things sitting in base folder, that means that it's applicable to all environments. So that's an example of VNet specification. So we have AKS, App Gateway v1, v2, APIM, Bastion, Test VM, and subnet gateway. So 6 subnets, and the only thing I specify in base is the range, means /20 was /25. So, and this example of for a lab environment, VNet configuration, the only thing I need to specify is IP range for blue and green environment. So, based on these two, those two configuration element, deployer will generate ARM template that will deploy VNet to lab environment. And so here is an example of how our templates are structured. So we have, for example, AKS, APIM, inside Bastion, and different things. So on each folder either contains ARM template or parameter files, or both. So depending on how we run it. So that's a deployer. So now let's switch to Azure load balancing options. Because when we talk about immutable infrastructure, then we always need to have something on top of our infrastructure that will orchestrate the traffic. So, and on Azure, there are 4 products in load balancing category. That's Azure Front Door, Traffic Manager, Application Gateway, and Azure Load Balancer. And here it's marked as global or regional. So global means that those products operate on global level, so they orchestrate traffic between the regions. And regional means that Application Gateway and Azure Load Balancer, so they normally orchestrate traffic within either within a resource group or within a region. And another differentiation is that, for example, Traffic Manager and Load Balancer, they can operate with non-HTTP traffic. And while Azure Front Door and Application Gateway, they only operate on HTTP or HTTPS traffic. And we're going to talk only about Azure Front Door and Traffic Manager. So, Traffic Manager is a DNS-based traffic load balancer. And when you use Traffic Manager, so it works the way that a client, if you have some applications if you have a website and you have traffic manager in front, so then when the client calls your website, traffic manager identify what is the fastest backend available for your client. Or for example, if you configure some priority, and then it will give client the IP address or DNS name, and then client actually will call this endpoint directly. So the traffic itself doesn't go through traffic manager. And just some characteristic of traffic manager, so it increases application availability. And that's typical disaster recovery scenario that you may have two applications running on different regions, for example, West Europe and North Europe, and then traffic manager in front, and then traffic manager can be configured that if West Europe goes down, the traffic will be automatically redirected to available region. So it also can improve your application performance, and that means that, let's say, if you deploy your application in different regions, and then when client calls your application, traffic manager will identify what is the closest to your client in terms of latency endpoint and will route the traffic there. So traffic manager has a concept of routing profiles, and there are 4 available: priority, weighted, performance, and geographic. And we're gonna cover first 2, priority and weighted, because they are useful when you work with immutable infrastructure. So priority, when you configure traffic manager with a profile as a priority profile, then traffic manager contains a prioritized list of service endpoints. So 1, 2, 3, 4, 5, 6, 7, and so on. And basically, the lower priority, the higher priority. So a typical example can be that we have 2 environments, production and disaster recovery. So production runs on West Europe and disaster recovery on North Europe. And then you configure that your disaster recovery traffic manager has 2 endpoints, production and disaster recovery with priority 1 and 2. And that means that when traffic reach traffic manager checks, okay, production priority 1, are you alive? Yes, traffic goes there. So for example, if West Europe goes down, then traffic manager will ask, okay, production, are you alive? No, go there. So that's the way how it orchestrates. And then, for example, in production, we may have a VCE with a blue-green. So, and then we can configure our traffic manager also with 2 endpoints. And that like priority only applicable if you don't use canary. So if you use canary, then you can't use priority, because priority is basically on-off. Right. So, and then in production, for example, we configure that blue is currently active. So, and that's indicate here. So 1 and online. And then it's multiple ways you can implement the switch. So the switch can be, you change the status of the endpoint. So for example, if I want to switch to green, so then I update traffic manager and say, okay, green is online and blue is offline, and then it will orchestrate the traffic. So the next profile type is weighted. And that's, it works the way that you assigned a weight to your endpoint. So weight is basically a number from 1 to 1,000. And then when traffic reaches the traffic manager randomly picks the endpoint, and the probability of traffic going to one endpoint or another is based on this weight number. But in my head, it's much more easy to think about it as a percentage. So I can say if I want to send 10% of traffic to blue, then I specify weight as 10 and 90. So that's weighted. And lesson learned for us in VCE with the traffic manager is that because traffic manager operates with DNS caching, and that comes with this TTL, and every time when we do a switch, it will take some time before the traffic start like going to the new endpoint. Because yeah, if TTL is configured for example, half an hour, then you will wait a half an hour before traffic will be switched. And we also experience that sometimes, even though we some hours after the switch, we still have like very little amount of traffic, but still coming to the old endpoint. And another thing that we just it's not an issue, it's just more like comment, is that the way how you configure a traffic manager is that if you have it operates per domain. So let's say if you have foo vips.no and bar vips.no, then you will have two traffic managers. So, and if you, for example, have multiple things running on your infrastructure assigned to different domains, then you will have a lot of traffic managers. So the front door, that's another product, also a global level load balancer. It operates on HTTP. And one thing about traffic manager, it operates not only HTTP, HTTPS, it can also serve the TCP traffic, for example. But front door, it's only HTTP, HTTPS, level 7 load balancer. And it works the way that Azure has this global network. It's a lot of networking between continents, and those orange dots, this is something called point of presence. So, and if you deploy front door in front of your web application, so then traffic will travel the following way. So it find the closest POP from your client, and then once the packet enters the Azure Global WAN, so then the request will be sent over extremely low latency connection between two endpoints. So basically, the second packet comes here, it just travels really quickly to another point of presence, and then to endpoint. And another thing that we find very attractive is that it supports multiple site hosting. So that means that even if I have multiple domains, I still can have only one instance of front door that will that I need to configure the traffic between them. And routing methods, it's pretty much the same. It's latency and priority and wait. So that means that if you're planning to use front door as your kind of immutable infrastructure orchestrator, then most likely you will gonna use a priority and weighted profiles. So and another test that we want to do with with front door is actually we want to test what would be the performance improvements, because like this fact that the Microsoft global network will be used, I think it looks very promising, and we expect to have some performance improvements as well. As I said, we don't have production experience working with front door, but the proof of concept that we run shows us quite a good result. So, and first thing, that faster switch time. So when we do the switch, it takes approximately 2 minutes before this change actually deployed to all these POPs. And after 2 minutes, it switched, and then the traffic it's 100% will be redirected to the proper endpoint. And as I said, multiple site hosting, this is also things that will simplify the number of infrastructure components in our infrastructure. So to wrap things up, so this mutable, immutable, that's I think we should treat it as a sort of tools in our architectural tool belt. So there are some cases where immutable infrastructure works fine, and some cases where mutable infrastructure works also fine. And I also think that hybrid solution, when you have infrastructure and some of the components are mutable and some of them are immutable, that this is also valid, because we should be pragmatic and practical. So do not pick the lowest common denominator. That means that, like, when you look at your infrastructure, you don't need to apply, okay, everything should be immutable or everything should be mutable. So you should look at your infrastructure, understand your infrastructure, understand what is the impact of different components of your infrastructure on your business. You should understand what is SLA that you're operating with, and then design your system and make your decisions based on this information. Also, you should learn Azure products, because Microsoft product teams, they constantly improving their products. And just to give you an example, AKS, 2 years ago, or even 1 year ago, it was not possible to update your VM size. This week, they actually put it to the private preview that now you can. And another thing is that AKS today supports multiple pools. So that means that technically you can implement immutable infrastructure in one instance and then have, for example, blue-green VM pools. So, but in our case, we evaluated this option, but we decided that for us, it's much more easy just to spin up a new infrastructure and deploy things and be done with this, instead of putting this complexity into implementing these multiple pools in Kubernetes. But at the same time, it's possible, and you should definitely consider it if you want to. And automation. So everything should be automated. So I think you should invest a lot of time and energy in automation, and then your life will be much more easy. And testing, of course. So testing, any sort of testing, and especially end-to-end, because if you're able to test things yourself, then you don't need to involve other teams, and then it will give you much more flexibility and possibility to upgrade your infrastructure. So, and that was it. So what I wanted to present to you. So if you have any question, you can ask them by voice, or you can send them to the Slack and I will answer them.
Hi.
Right.
Thank you so much. I'm just I'm just looking at chat here in case anyone has a question there. Let's see. And I don't know coming up. So I think you are all set. Although I would check, like I said, Slack, because there's often a lot of chatter there. So I'm going to go ahead and stop the recording.
Yep, thanks.
Okay, thank you so much.
Thank you for supporting.